Thanks everybody for joining. We're going to get rolling because this is, we have a lot of content to cover and I want to make sure we get all of it. So thanks for joining. This is the power of generative AI in business. My name is Cameron Duncan. I am the co-founder and CEO of Hallian Technologies. We developed a platform called Hallian AI. So Hallian Technologies is an end-to-end partner that helps our clients build effective, scalable, and powerful AI assistants and workflows and automations all in one place with Hallian AI, which is our privately hosted AI integration platform. As for me, I've spent 14 years in the manufacturing industry prior to building this business. I have a background in automotive, power gen, and electric vehicles. I held a variety of leadership roles within those organizations, also serving as chief of staff at a publicly traded company. I developed an obsession with the potential of generative AI and what it can do into businesses, and that's what led us to launch our company here. Moving on, before I really get into the generative AI stuff, I want to make a comment just about IT and IT tools in general. My perspective is that the purpose of IT is to drive intrinsic value into the business. And that intrinsic value comes from the business actually making money. Intrinsic value really comes through three primary ways. That's either you can get the revenue up, you can get the cost down, or you can generate profitable new business. So if a software or a piece of technology, no matter how shiny it is, does not do those things, then it doesn't make sense to deploy it within a business. So I'd like you to keep that in mind as we go through this technology and making sure that you're thinking through how could this add value into our organization. The goal for this webinar is to take you from the left side, which you may be confused about how this technology works, or even what it means or how it can be applied, or you may even be saying, you've seen the technology and you're like, so what? This is just the latest fad. My goal here is to take you from that place to a conceptual understanding of generative AI and then the underlying principles for the technology. We're going to cover the potential and scale of generative AI, what it can do, how it works, techniques to apply it to businesses, and risks and concerns. Okay, so let's just start off with talking about what I call the generative AI hype train. So this is a bit tongue-in-cheek, but it is true that a lot of the stuff in the AI space is, for lack of a better term, BS. Not everything that's called AI is actually AI, and not everything that's called AI is actually generative AI. But this is not a fad, and that's what we'll be talking about in this presentation. Just a few quick stats. This came from Google. Google did a survey about 3 to 4 months ago of approximately 2,000 senior executives at some organizations. All of those organizations had more than $10 million in revenue. 86% of the companies that were using generative AI in production expect a revenue growth of 6% or more just by using those generative AI tools they put out there. 45% of the organizations that said they had generative AI in production reported that their employee productivity doubled. It's an absurd statistic, but that came directly from Google. So even if it was half of that, it's still an incredible statistic to cite. And then lastly, 85% of organizations said that they saw an increased engagement and improved employee satisfaction after rolling out these tools. So what I'm going to convince you of is that generative AI is a fundamental shift in what is possible for both individuals and for businesses. There's a gentleman named Reid Hoffman. Reid Hoffman is an entrepreneur, a podcaster, and author. He's best known as the co-founder of LinkedIn. He coined the phrase cognitive industrial revolution, and he used that on purpose. So he was trying to communicate the scale of which that he believes that generative AI technology is likened to. So just as steam power transformed manufacturing and transportation and construction, generative AI is revolutionizing all language-based capabilities. The difference between what's happening now and the Industrial Revolution is the speed at which this is happening. If when a new feature or platform or tool is launched by some of these larger organizations like OpenAI or Anthropic, that tool is being used by up to like 1 billion people in a matter of days, not in weeks, not in months, not in years. It's happening incredibly quickly and it's changing very quickly. But there are principles at play that we'll be talking about today. So here's the official agenda. We're going to start with what is generative AI. Then we're going to do a crash course for leaders in generative AI. We're then going to move to applying generative AI inside of businesses. We're going to do a quick demo displaying some of the techniques that we've talked about in number 3. Fifth is we'll talk about risks and concerns. And then lastly, we'll do some homework and next steps. And we have time, we'll try to do some Q&A at the end. All right, so what is generative AI? We are going to start with a quick demo using ChatGPT. I'm going to start a new chat. I'm just going to ask a few questions. So let's do something pretty off the wall. So I'm going to say, okay, so can you list all of the Russian czars from 1600 to 1700 and provide a 2-sentence synopsis of what they did in power? Let's see how it responds. Oh, there's more Russian czars than I expected in 1600s, but you get the point. You can ask it effectively any question in English, and it will respond highly accurately and very, very quickly. I could then take this and say, can you write a 4-paragraph research paper on this topic? So again, pretty remarkable how quickly it does this. The next questions that I could ask are, could you make it sound like an 8th grader? I could ask it to do something even crazier, like, could you rewrite this as if a pirate were the author? So a bit of a silly example, but the point here is how quickly it can change the tone and the context of how it's responding using the exact same content. So just a quick snapshot of what is possible using this technology. So it's generating content based off of things that it was trained on. If I go back to our presentation. All right, generative AI capabilities. So what you saw is natural language processing. It understands English and it responds in English. It also was trained on an enormous amount of data, basically everything that was publicly available. So I would say it's 90th percentile in almost every field that you can imagine. It's incredibly fast. As you saw, it generated content very, very, very quickly. So I call that speed to insights. It's taking a large amount of data and then summarizing it and giving you what you need to know. And then lastly, it is highly accurate. I'm not saying that it's perfect, and we'll talk about something called hallucinations later, but in general, it is a very, very accurate technology. Generative AI creates meaning out of vast amounts of unstructured data. Where generative AI lands in the AI landscape is it's within the entire bucket of artificial intelligence, and then it's based off of machine learning and deep learning concepts to create what we call generative AI today. Some examples of generative AI are OpenAI's ChatGPT. That is the most popular version of this, but there's thousands of similar large language models like ChatGPT. Claude is a application that was built by Anthropic. Snowflake has something called Arctic. Meta, which is Facebook, has a tool called Llama. And again, there are many, many more large language models that are out there. I want to quickly show a slide on history of generative AI. This isn't a history lesson, But there's a big takeaway here, and the takeaway is that generative AI did not happen overnight. A strong foundation for the technology has been built over the last 50 years. Um, and what's happened is that the computing power has caught up with the vision. And we are now just seeing much of that work come to fruition in the form of generative AI. All right, ready for a crash course in generative AI? Here we go. All right, this is this is the big reveal. This is the secret. And I would say that understanding the content on this slide is the most important thing that you could get out of this webinar. And that is that generative AI is a prediction machine. Prediction machine, I got that term from a few economists. You can see them referenced here. They wrote a book called Prediction Machines. I think it came out in 2018 or so. Because what generative AI does is it works by pattern recognition and prediction. What I mean by that, let's take an example on the left-hand side. If you were to type something, a prompt saying, I like, generative AI will guess the probability of the next word or token that comes after the word like. So if you say I like, the probability that you're going to say that you is going to be the next word is 38%. And if you write I like you, the probability that a period is going to come after that is 55%. So this is what generative AI is doing. It is predicting the next word and generating information based off of the context that preceded it. The takeaway here is that generative AI, though it seems intelligent, it's not, or at least not in the conventional way that you and I think. It is effectively guessing based off of the training that has been given. And if you can grasp this concept that generative AI is a prediction machine, then you will be well on your way to enabling your business to use this technology in productive and effective ways. All right, let's get into the first big term. The first big term that I want everybody on this webinar to understand is large language model. A large language model is an AI model that's trained on vast amounts of text data to understand, generate, and respond to human language. Again, the most popular version of this is ChatGPT. Some features of this is that it's trained on huge data sets. I mean, billions and billions of words from books and articles and websites. It's learned patterns in language, so meaning, grammar, context, and it's incredibly versatile. It can perform tasks like writing, customer support, it can do content creation, it can translate languages, it can do all types of stuff. And how it works, again, is that it predicts the next word in a sentence based off of the context of previous words. It generates coherent text, it answers questions, it summarizes information, and again, it can even translate languages. We're going to go through a few quick definitions before we really launch into it. So the first generative AI definition to understand is prompting. This is the process of giving the LLM a specific input, called a prompt, to generate a desired output or response. So this is like the question that you asked when I was asking ChatGPT, list out all the Russian czars. That was my prompt to the large language model. Tokens are how large language models break down text. This is how it thinks about it. It breaks down text into smaller units called tokens, which is a word or even a part of a word. And then the model uses that to generate its response. Each model does have a token limit. So for example, ChatGPT 3 has a token limit of a little bit over 4,000 tokens. Tokens are important for a bunch of reasons, but one of the reasons it's important is that tokens are, if you deploy this technology in your business, tokens are your variable cost. You get charged by the token to use the technology. Context window is the maximum amount of text in tokens that the model can remember at once. So if you exceed that limit, parts of the conversation that are earlier are forgotten. There's a maximum amount of tokens. Again, ChatGPT 3 has a little over 4,000 tokens. Once you get to that limit, if you have a long string of text, you will start, the tool will start forgetting. It loses that short-term memory of what was in that context window. Prompt engineering is the technique of crafting prompts in a precise way to get the most accurate and useful response from the LLM. And we have a slide on prompt engineering later, and we'll do some examples with that. And the last term is corpus. Corpus is that large amount of text data that's used to train the large language model. That could include sources like books and articles and websites, basically anything in the public domain. It was used for that corpus, and it enables the model to learn patterns in languages. Now that we've seen what generative AI can do and some basic definitions, I want to talk through some limitations of out-of-the-box LLMs. Most LLMs, or large language models, are generalists, though they are certainly getting better. We have seen, though we've seen what it can do, it's not infallible, and understanding the limitations will help you understand when the tools are appropriate and when it may not be the most effective solution for your business. It is worth noting that there are workarounds to many of these limitations, and we'll talk about some of those workarounds later in the presentation. The first one is context window limit. I mentioned context window earlier. As a reminder, context window is the total amount of tokens that any LLM can process at a given amount of time. That is a specified window. So what this means is that you couldn't upload all of the Harry Potter series to a large language model and have it summarize it for you, because it would be too much information for the large language model to handle at any given time. So understanding that there's a context window limit is an important thing to consider when you're trying to design solutions using generative AI. Lack of real-time knowledge. The corpus that these large language models are trained on are static. It is a set in stone amount of data that it was trained on, and anything after that, the large language model, without anything else, does not have the answer for it. So if you were to go to ChatGPT, before they rolled out some of their the newer things that they're using to solve some of these problems, but if just out of the box, if you were to ask it a question like who won the Super Bowl in 2024, and you're using a model that was trained on 2023 data, it would not be able to answer that question. Hallucinations. So we talked about this being a prediction machine. So it is generating information, and as it generates information, if it doesn't have an answer that it has been trained on, these tools will still generate an answer that sounds convincing, and this is what's called a hallucination. But because the tools, the large language model, doesn't actually know what's true or false, it just knows what it's been trained on. So there are workarounds to hallucinations as well, and we'll talk about that later in the presentation. It doesn't have the ability to reason or think. By reason or think, I mean the ability to interpret what it's responded and decide whether or not that is the right thing to do. Again, it is just generating information based off of the context that it was given. Data bias. Based off of the corpus of information that was put into that large language model, it could have specific biases in that data. So for example, let's say you have a business that is in multiple countries and you're using a large language model that was primarily trained on American content. It might be biased towards American information, not for content for another country. Prompt quality. I have a slide specifically for prompt quality later, but what you put into the tool is often what you will be able to get out. The quality of your prompt is incredibly important in using the technology. And then last is the lack of domain-specific knowledge. Large language models by nature are generalists, and if you have something hyper-specific in your business or in your industry, it might not be trained on that specific knowledge. So think like the medical field or legal professions. There are certain large language models that are domain specific for those knowledge segments. But in general, out of the box, most large language models have some blind spots in domain specific knowledge. The ones in blue are the limitations that we're going to be talking about later in this presentation. All right, there are two types of problems that generative AI can solve. And these are the types of problems that I am interested in helping you solve and helping you think through. The first types of problems are efficiency problems. This is quantity. So it's how fast and how much of something can you do. So efficiency is how fast you get to an answer. It's like search, Q&A. Generating content. So a simple example is creating an email or creating some marketing copy. Generating content very, very quickly, being able to do a lot at scale. So pulling information out of a CRM and then using that to create specific content for each of your customers, for example, would be an example of speed at scale. And then lastly is synthesizing knowledge very, very quickly, summarizing information. So that's a quantity or efficiency play. The other type of problem that it can solve is an effectiveness problem. And effectiveness is the quality of the response. So what I mean by that is, can you get better results by using the tool? So not can you only be efficient, but can you be more effective? So better results, better ideation and brainstorming, more innovative, being more personalized, which drives better response on something like marketing. The takeaway here is that efficiency certainly matters, and most of the initial rollouts of this technology they're almost always efficiency plays, but effectiveness is what transforms organizations. Moving on to applications to business, I'm going to show a quick video.
We created Lily to ensure that all of our colleagues have the deepest and broadest access to our best insights so they can activate them with our clients. We took 100 years of McKinsey insight and expertise and put it into a GPT generative AI-like experience so that it would be available to anyone in the palm of your hand or on your desktop.
The firm had looked for a long time on ways to make the knowledge that we have accessible and make people aware that we had it. So the beauty of Lily is that, like, we didn't go and look for a way to use generative AI. We had a really valuable, important problem to solve, and generative AI was just one of the pieces in bringing it together.
We took a very measured and strategic approach to slowly rolling it out and making sure at each stage that we rolled it out, the experience was what we wanted and the bar to adoption was as low as possible. As of today, Lily is across 100% of McKinsey, and about 72% of our colleagues use it every single month. We have over 3.5 million prompts answered, and every week we add more than 120,000 new prompts from colleagues all across the world on hundreds of different topics.
When you ask Lily a question, first it will look to understand the intent of what you're asking and identify the right data sources to go and find. Then it will rephrase the question you asked into a search phrase that goes into our client capabilities mode and pulls out the data sources. Its goal is to summarize, synthesize, bring back, generated insights, which is why it's called generative AI. What I found is it gets me somewhere between a 20% to a 60% answer in about 15 seconds. And once I really honed in on that time savings, I realized how powerful it was.
The productivity gains are profound, literally. In 2 minutes, I had what would have taken me the better part of an afternoon to go through and better understand. The ability to summarize huge documents, or huge number of documents, or huge corpus of information. Like, you just, especially qualitative, unstructured information, you just can't do that any other way.
The people who've really cracked how to use Lily are telling us that they are 20% faster, more productive, and the answers they're able to bring to their clients are 20% better because of Lily.
The future of Lily will be driven partially by how we use it and partially by the evolution of the technology. I expect there's going to be a lot more opportunities to do computational skills, to do automation of various tasks and work, and to engage our clients in fundamentally new ways.
People are going to be able to bring the best of what they have, their private niche program building information, their practice information to Lily, and leverage the power of generative AI on top of it.
I think we're just at the beginning. This is going to be, a part of, but not the whole recipe to unlocking a lot of value for us as a firm.
Generative AI technology is here to stay. It's going to be part of our daily lives, it's going to be part of our work lives, and it's going to reshape and reconfigure how organizations work and operate. However, like any disruptive technology, it needs a business model that's going to scale and problems that it can uniquely solve. And Lily really is doing both for McKinsey & Company.
Okay, so there's a reason I showed this video, because I think it's one of the most effective ways that I've seen of an organization using generative AI technology. So McKinsey built an entire self-grown system using generative AI to get to all of the firm's knowledge over the last 100 years. So it's completely rewiring how they work, and it's making them way more productive and way more effective with their clients. Here's a quick quote. This quote came from a guy named Asaf Basu, who is the co-founder of a company called Persado. And this is slightly paraphrased, but it's still effectively what he said. To produce effective outputs at scale, enterprise generative AI requires more advanced capabilities in the form of either one, specialized models that are trained on real-world data relevant to the problem you're trying to solve. Number two, knowledge bases containing insights, or three, some type of problem-centric, repeatable prompts that you can do over and over and over again. All right, there are two places that generative AI excels inside of industries and functions. The first function these are knowledge-based industries and functions. So think like white-collar work. White-collar work, I mean engineers, attorneys, research, healthcare, executives, etc. Anything where knowledge is at a premium is a perfect place for generative AI to add value inside of an organization. The second place that generative AI excels is processing unstructured types of data. In my experience, and from most of the people that I talk to, the majority of data in organizations is not neatly in a database. So think about all of the presentations, all of the strategy documents, all of the technical documents that you have, product specification sheets, work instructions, you name it. All of this stuff these are examples of unstructured types of data. And generative AI is amazing at pulling insights out of unstructured types of data. All right, I'm going to do a quick example talking through how I think about large language models. So when I worked at GE, there was a guy that I worked with. His name was Brad, and Brad was the chief engineer or principal engineer at in the organization that I was a part of. And Brad seemed to know effectively everything about gas turbines and gas turbine fired power plants. He wrote the design practices. He knew everything inside and out. He was also like one of the smartest people that I've ever known. And everyone, including me, went to Brad for answers. Anytime you had a question, anything you couldn't solve or anything you couldn't find, you just went to Brad, and Brad would be like, go here, read this. He just always seemed to know the answer to everything. So the way that I think about LLMs is similar to what Brad was doing in that organization. So I call it Brad 2. Brad 2 is 90th percentile smartest guy in effectively every domain, but he doesn't get tired and he's crazy fast. This is how I often think about large language models. But the thing with Brad 2 is that he's a bit odd. So he only speaks if he's spoken to. He can easily misunderstand what you say or what you mean, and he can often miss context that seems intuitive to us, and he just won't know it. But the vision is a Brad 2 that knows everything about your business and everyone has access to him. So similar to how ChatGPT seems to know effectively everything from the internet, the vision is a ChatGPT that knows everything about your organization. But there's a big problem here. And the big problem is that Brad 2 basically knows nothing worthwhile about your organization except for what it knows from the internet. It's too general to actually be effective. It's like a really smart person looking in from the outside, but not being contextually aware enough about what's going on inside of an organization to be actually useful in solving business problems that need internal company context. Okay, right? So the rest of this presentation is about creating the conditions that enable Brad 2 to be put to work effectively inside of your organization. We talked about these large language models and the limitations earlier. We're going to do the first example is going to be with prompt quality. Okay, so prompt engineering. Prompt engineering is the technique of crafting prompts in a precise way to get the most accurate and useful response from the large language model. We're going to do another example with ChatGPT. I'm going to ask it to make a meal plan for the week, and then we're going to ask it for a more detailed meal plan. So I'm going to go back to ChatGPT. I'm going to start a new chat. Make me a meal plan for the week. Okay, so it made me a meal plan for the week. Monday, Tuesday, Wednesday, Thursday, Friday, breakfast, lunch, and dinner. It has some spaghetti. It has a few various things in here. It's got, I noticed it has walnuts, but this isn't actually what I really wanted. So if I go back to here, I'm going to type in another prompt that I already wrote, and I'm going to ping this in. And let's read this prompt together. Make a dinner meal plan for my family this week, Monday through Friday. The family is me, my husband, a 5-year-old, and a 7-year-old. The 5-year-old has a tree nut allergy. We would like to limit pasta to only one day this week. Do not include any red meat. No meal should take longer than 30 minutes. Okay. And then I said, generate a concise list of dinner for each day, followed by detailed recipes for each, and then a complete shopping list with quantities. I'm going to press go, and I want you to see the difference in response. So I'm not going to go through all of this, but I think you're starting to see the point. So I wrote that prompt. That prompt definitely took me longer to write than the first prompt, write me a meal plan for the week. But because I took the time, an extra 2 to 3 minutes, to write exactly what I wanted, it gave me a much better response. And it gives me the shopping list, vegetables, meat, packages, all the things that I asked for, which is, I mean, frankly, pretty remarkable. So with prompt engineering, what we mean this is clarity is key. So be specific and be concise with your input and guide the AI toward the response that you want. Context does matter, so make sure you provide enough context to ensure that the scope or topic is understood. This is an iterative process. By that, I mean refining prompts through trial and error, like doing question and answer back and forth until you get the response that you want, is actually expected. It is totally fine to continually revise your prompts to get more and more quality responses from the AI. Task orientation, give it a specific task. So if you're asking something to summarize, make sure you say summarize this. If you want it to generate something, say generate. If you want it to do a detailed analysis, ask it to do an analysis. Give it a task to solve. And then lastly is use constraints. You want to put some type of box around the response. So giving limitations or even giving examples of what you want the response to look like can help the AI focus and produce better results for you. That's prompt engineering. Moving on to other LLM limitations. We're going to talk about real-time knowledge, hallucinations, data bias, and lack of domain-specific knowledge in this next section. There are two primary ways to enhance large language models for use in a business context. All right. This is taking an out-of-the-box LLM and then making it so it works inside of your business. The first way is training the model, and the second way is using an external library. Training the model is called fine-tuning. So this is training the model for a specific purpose. And then on the external library side, this methodology is called RAG. And RAG is retrieval augmented generation. I have slides on both of these, and we're going to get into it right now. Fine-tuning is the process of training a pre-existing large language model on specific data to adapt it for a particular task or industry. All right. This is what it looks like. Over here on the right-hand side, we have this large language model. Just think about this as like ChatGPT. And then you add some type of curated data set with there are many types of ways that you can do this training, and that is not the point of this presentation. But what I want you to understand is the concept here. So we're taking a curated data set and then using that to effectively shrink the large language model and give it more context to respond how you want it to respond. what this does is it's doing a custom adaptation to that large language model, tailoring the large language model to meet a specific need of an industry or the specific need of a task. It does enhance accuracy inside of the domain that you're asking it to be trained on for that relevant data. It's what this allows you to do is do domain specialization. So you're equipping a model with expertise in niche areas or unique business contexts, and it increases the relevance of the generated responses. The reason people do finely tuned models is because for an industry or a task is because it is much easier than building a large language model from scratch. If you can take a large language model that already understands the context of words, that has been trained on a corpus of data, you can take that and hone it to a particular task without doing the underlying deep learning and neural networks that are required to build the large language model in the first place. Some applications of this are asking a large language model to write in a style. So for example, if you have a particular brand voice for marketing or for customer-facing chatbots, it makes a lot of sense. It also makes a lot of sense in hyper-specific data sets that might not have been a part of the original corpus for that large language model. By that, I mean, like, just think like healthcare field or the legal field. Good examples of where a finely tuned model makes a lot of sense. The next way, this is using an external data set. This is called retrieval augmented generation, or RAG. So RAG, or retrieval augmented generation, enhances large language models by retrieving relevant information from external sources to improve the accuracy and relevance of its responses. This is typically what it looks like when you talk to a large language model like ChatGPT. So we did this earlier, right? We asked a prompt, went to the large language model, and then I got a response out. This is what RAG does. So you take your prompt in, and then it goes through a search mechanism. So the prompt is effectively intercepted. It goes to an external data set, grabs the information that it finds relevant, pulls out that retrieved information. So this is augmenting your prompt and then going to the large language model to generate a response. So it's retrieval and then augmenting the prompt to generate a new response. That's where RAG comes from. RAG is great for contextual relevance. It allows models to access up-to-date information, ensuring those responses are accurate and contextually appropriate for the use that you're using. It enhances the knowledge base, so it integrates external databases. It improves efficiency by minimizing the reliance on static knowledge. So the ability to dynamically adapt the external data set is what really is a huge feature of using RAG. And then lastly, the use cases. This is ideal for like customer support or content creation or data-driven insights where you want to have up-to-date information. I have, this slide is going to do a quick comparison of fine-tuning and RAG. The soundbite for each of them are for fine-tuning. I don't remember where I got this from. It's not mine. I read it somewhere, but I think it's good and it's right. Fine tuning is for form, not really for facts. But RAG is enhancing large language models with your data. The accuracy of the two, RAG is much more accurate than fine tuning. Difficulty in deployment, RAG is relatively easier than fine tuning to deploy. For flexibility, I mentioned that you can modify the external data set as often as really you need to, getting up-to-date information, allowing it to be very, very flexible. With fine-tuning, anytime that something changes in your training, you have to then retrain that model. So it makes it a little bit less flexible than a RAG methodology. And then last is cost. Relatively, RAG is a less expensive alternative than fine-tuning. Fine-tuning is particular and requires a lot of work, and the cost of that goes up. So the takeaway from this is that though fine-tuning has its uses, we as Hallian Technologies, we strongly recommend RAG for your first projects in your business. we recommend it for all of these reasons that we just talked through, and it's also understandable and explainable. You can see how you're generating your responses. So we're going to do a quick example that I mentioned earlier. I sent everybody a zip folder that had a bunch of policies. Those policies are HR and corporate policies. I pulled them off of the internet, and then I modified them to a company named Superstore, and I just gave it just some generic HR stuff inside of it. Some examples of the policies that are inside of this are employee handbooks, bereavement leave, dress code, cell phone use, hiring process, code of conduct, drug and alcohol policy. I think you get the point. So with that said, I'm just going to jump directly into the example. And full disclosure, this is our platform, but it's an effective way to show just a quick example. I go to HR policies. I've been at the company for 3 years. How much PTO do I have? And voila, you get an answer. Let's just talk through this a little bit. So it responded, right? It said you have 15 days per year. Here's a summary of the PTO accrual. You've been at the company for 3 years. Here's how the accrual rate works, and here's how we came up with the 15 days per year. You can carry over a maximum, and then it also cites a source. So it cited pay time off with accrual and carryover provisions document. That sounds reasonable. If I go down here to search results, I want you to see this. So this is what's happening. Inside of this, we've uploaded these documents, and we've done a lot of things on the back end to vectorize those documents and create chunks of the documents that we uploaded that allows the AI to very quickly go in and retrieve information that's relevant and pull that out and then augment it with that large language model. For that question, you can see that it hit a few documents. The first one that it hit was that paid time off document, but then it also hit a bunch of stuff in the employee handbook. It looked at personal leave of absence policy and a few other things in here, right? So this is how it works. For each of these, there's a chunk of text that it thought was relevant, and it pulled all of those in. So that's how it works. Let's ask a different question. A favorite question is, can I wear flip-flops to work? So again, it is taking that information and responding to the answer, and it says, hey, flip-flops are inappropriate for the workplace according to the business dress code policy. But you can do a lot of stuff with this. So I could say, okay, so not that you would do this, but just as an example, I would like the dress code policy to be a bit more modern. Can you draft an example clause that we could add to the dress code document to enable employees to wear something like flip-flops? So let's see what it comes up with. So it gave us a response. You could look at it, you could modify it. We could, again, go through prompt engineering and modify this as we go. And then you could get that. And if it makes sense, you could add that to the policy, run it through the appropriate approvals, and then update the policy that's a part of this RAG retrieval augmented generation system. Okay, so that is RAG in a nutshell. So there are many, many, many use cases of generative AI inside of businesses. I just threw a few quick examples on here for manufacturing. I'm not going to go through all of these in detail because, frankly, we're coming up on time here. But I just want to give a few quick examples. Maybe I can do quality. So say you're a quality engineer, you're in the quality department instead of a manufacturing organization. How could you use generative AI? Like, where would it make sense? You could use generative AI to generate corrective action plans by consulting past quality issues. For example, you could quickly retrieve guidelines and best practices instantly. You could also access compliance documentation like ISO or IATF, or if you have a quality management system, a QMS, you could have everyone in the company have instant access to all of those policies and those processes just by asking a chat without even having to go to the document itself. It could pull out the correct answer and give that to the person that's asking the question. Again, this is about speed to insights and being able to be effective and efficient in how you do your work inside of the quality organization. But I put examples in here for maintenance, for engineering, for sales, for marketing, and for manufacturing. What I wanted to share is that there's there's so many functions inside of manufacturing. Every single one of these functions can use generative AI in a way that would make them more efficient and more effective. So finance, accounting, production scheduling, and SIOP, investor relationships, all of this stuff. There are clear use cases to use generative AI in manufacturing and in various departments inside of any organization. Or in addition to specific use cases, similar to what McKinsey did in the video that we saw, you can drive value across your entire organization by revolutionizing internal knowledge management systems. An example of that was giving everybody access to your quality management system through a chat, for example. All right, in the last few minutes, we're going to go through a few quick risks. Before I get into these risks, there are ways to manage every single one of these risks, though we will not be covering those in this presentation for time. But I wanted you to be aware that there are ways to manage all of these, but you need to be aware of them. So the first one, and the one that I hear most often, is data privacy and security. Generative AI often requires access to sensitive data. And so if it's not managed properly, if the data is not managed properly, or a generative AI process as a whole is not managed, it can lead to data breaches or misuse of personal information or customer information. On strategy, without a clear strategy for implementing generative AI, businesses will struggle to align the technology with their goals, which this is back to what is the purpose of IT? The purpose of IT is to drive intrinsic value. So you need to have a strategy for your business that generative AI supports, not the other way around. It can't be generative AI first. It needs to be business first, generative AI supports separate. Data governance. Without a strong data governance structure, including lack of centralization of data, you will get inconsistent data quality and accessibility problems, and that will undermine the effectiveness of any generative AI application that you put on top of that data. Generative AI, just like anything else that's software related, is garbage in, garbage out. If you feed it a bunch of bad, inaccurate information, it will give you bad and inaccurate responses. Lack of technical expertise. Many organizations, especially like medium-sized organizations, may face some challenges in utilizing generative AI due to just general lack of in-house expertise, which can create challenges when you're trying to roll out this information, this type of technology. And so what we see is that most medium-sized businesses either need to hire in someone that has the expertise, or they need to have an effective partner to help them implement. And then last is cost uncertainty. The financial implications of implementing generative AI must be fully understood, because there are potential hidden costs like integration and maintenance, and potential need for extra additional resources that may not be fully understood when you launch into doing generative AI inside of your business. And the last risk that I want to show is the concept of shadow AI. This is an emerging security risk for businesses. How I define shadow AI is it's the individual use of generative AI tools by employees to help them do their job more efficiently or more effectively. Employees are not dumb, right? They know that this technology is out there and they want to do a good job. This is helping them do their job better and more effectively, which helps them elevate and work. Instead of spending a lot of time writing a report, maybe they can have generative AI help them write that report, and then they can spend more time solving problems. But there's problems with this, right? So the first problem is that there's no protection of sensitive data or of intellectual property, of trade secrets, and there's no control or oversight by the business of using this technology. So the takeaway that I want you guys to have here is that shadow AI, though individually useful, is and can be highly risky for the organization. All right, let's just move quickly into homework and next steps. Homework. This is what I recommend. So I think of using generative AI as kind of like riding a bike. So if you are interested in this technology, set aside 15 minutes a few times per week to experiment with the technology. Doing this will get your brain thinking of how you could use it inside of your business. Number two, if you don't have one already, create a corporate generative AI policy and roll that out for all of your employees. And third is I strongly recommend pull your team together because this technology is here and it's powerful. Brainstorm 3 use cases that your organization could use this technology, and think about ways that you could deploy it inside of your business using the techniques that we talked about earlier, like RAG and fine tuning. How would you architect a system to do what we talked about? Okay, that's it. So thanks everybody for joining. Again, just a quick note on our platform. So Hallian AI is a privately hosted AI integration platform designed to empower businesses to build their own AI solutions using their data, but without compromising the security of their intellectual property, trade secrets, or sensitive data. We are an end-to-end partner that helps our clients build effective, scalable, and powerful AI assistants, AI workflows, and automations. And this is all in one place. We've done the heavy lifting on the technology, giving our clients a no-code interface, to building the tools that we talked about today, integrating all of the best tools that are on the market. So if you want to learn more, you can follow us on LinkedIn or on YouTube, or you can visit our website at halliantech.com. And so with that, we got a few minutes. I'll stay on the line, and I'm happy to answer any questions. So let me see if anything's out there. So David Majors, hey David, hope you're well. Could the data set use something like maintain X, or do we have to export it into a different format? So the answer is yes. You could use something like maintain X. There are APIs out there. We would have to figure out exactly how to pipe into maintain X. There's 2 ways to do it. You could do a real-time API call to get the information out of a system like maintain X, or you could warehouse that information and have access to historical data that you could then query using a generative AI platform. Can you use Lily? So Lily is an internal McKinsey tool that they use for their organization to help them be more effective. The reason I showed the Lily example is because I think it helps people understand what is possible using the technology. So Gary, if you're still on, you said something about having more real world examples like construction. Could AI write RFQs for building supplies? The answer is yes, it could write an RFQ. It could send that out. It could collect responses. It could do all types of stuff. Now, you would have to design it to do that type of activity, but certainly you can build generative AI workflows that does that exact thing that you're talking about. If there are no other questions, we're right at time. So thanks everybody for joining. Hope you found it effective, and we'll talk soon.